first thing to hear, can everybody actually hear me? Because if you can't, this might be a slight waste of time. Nice. It sounds like people can hear me. It looks like there's about 30 seconds of delay or so. Well, some guys have no audio. Low. Let's have a look. Ah. Right, let's fiddle with these settings a bit. Bear with, this is probably going to take a bit of tweaking. Okay, how about now? This microphone is so close to my mouth, I think you can hear me breathing. That's horrible. Awesome. Right, there's about 20 seconds of delay, so if I'm a bit slow responding, that's why. Cool. Alright, so welcome to my first stream. What I'm going to go over today is what's called the dot product, which is an insanely useful bit of vector math that you can do. It's used for both materials and programming as well. So before I start, I'm just going to show you some of the stuff we're going to be building. So what we're going to do is I'm going to show you a particle system. I'm going to show you how you can hide the edges of a mesh when you're at certain angles using a dot product. I'm then going to show you how to build a really flexible Fresnel effect, so you can get a soft outer edge and a soft inner edge. And then after that, depending on how much time we've got, because I'm not sure how long this is going to take, we might be able to get into building an atmosphere shader for a planet as well. If anyone's seen my blue marble, we're going to be building something similar to that. Sound good? Okay, so I'm going to hide my face. So, dot products. Get your notebooks out. So they normally go by two names. They can be called the scalar product and the dot product, since they just return a single float value. Dot products can be both two-dimensional and three-dimensional. Technically they work in other dimensions as well. That's probably a bit outside the scope of this. So rather than me explain all this to you, I'm just going to show you a really simple visualization that I conveniently found yesterday online. So it's really simple. This is probably one of the simplest operations you can perform on any vectors. So you see this green line here. Now think of this as a range that goes from -1 all the way up to 1. So the closer these two vectors are, the closer to 1 we get. If we get to 90 degrees, the dot product will give us 0, and if we get to 180 degrees, so they're completely opposite to each other, it's now -1. Really simple. Hopefully you guys can see the links. If you want to go check this out yourself, you can. So basically, all the dot product does is tell you how close two vectors are to one another. That's, in layman's terms, that's about as simple as they get. So for us, rather than me show you with this, I'll show you in the engine. So this is a material editor. So I've put together a really simple material. This is a dot product node. To get one up, just right click, type in dot. And there you go. What I've created here are two vectors. They look like colours, but in Unreal terms they are kind of vectors. So vector 1 is, think of RGB as X, Y and Z. So currently this vector is pointing 100% in the X direction. Vector 2 is pointing 100% in the Y direction. Okay, and you can't see anything in the viewport, even though this is not an additive material. This is a completely sort of blank material. You can't see anything because the dot product is basically spitting out 0. Now if I change this so that these two vectors line up, you'll see we now get 1, so the entire sphere is coloured in one complete shade of white. If I hit 0.5, we'll get a value of 0.5. If I hit 0.2, we'll get a value of 0.2, so on and so forth. So you can go completely up and down. I can't show you what -1 looks like, but if I was to make that -1, technically the dot product is now giving us -1. Really simple stuff. Right. Now that out of the way, let's start putting this to use. So I'm going to open up a simple level where I'm going to show you one area where you can use this. So this is a really simple scene I put together. This is a rifle from the prototype weapons pack, which you can get on Marketplace. And all I've done is create a really simple particle system, which I'll show you here. So all we've got is a bit of mesh data to create that initial flash. I hope this is picking up, by the way. This is only 30 frames a second on Twitch, so these might be a bit too quick for everybody to see. So this is a mesh emitter, which is just a simple mesh, a bunch of crisscrosses. This is not the easiest way to preview this. It's just this mesh with a texture applied across it to make it look like a flash, right? That's a pretty standard way to make a muzzle flash. Alongside that, we've also got alongside that, I've also got some flares just to break it up a little bit, give it that battlefield look, and then we're just shooting some fake bullets out the end as well. So the finished result is this. Now what you'll notice is, from the side, as I move around this, everything looks okay. However, if I hide the bullets, turn those off, and you know what, I'll hide the flares as well. If I'm moving in front, you'll start to notice something. You can see that really ugly effect. So you can see the actual planes of the mesh as if you're looking straight down the mesh, and that's pretty horrible. Imagine you're kind of being shot at. You don't really want to see that in Battlefield or any kind of first-person shooter. And what's even worse is if you sit behind the gun, you'll start to see it there as well. That looks pretty horrific. And the flares and the bullets hide it a little bit, but you can still see those really sharp edges, and that's typically not something you want to see in a particle system. Particle systems should be all soft and fluffy. So with that in mind, we're going to alter this material, and we're going to use the dot product to fade it out as we start to look at the edges. So right now, if I tone this emissive strength down briefly, so right now this is what it is. It's just a sub-UV material with 6 different possible textures we can use. And as I get to the top and start looking down the top of this plane, you'll see that I can start seeing those sharp edges, and this is exactly the effect that you're seeing in the particle system. So as I move around, that's pretty ugly. Now what we're going to do is build a system so that as I get to the edge, this is going to fade to black. So basically as we're looking straight down the mesh, we'll completely hide this out. So I'm going to show you. Now rather than build this into the material directly, there's a concept I want people to try and get used to, is the idea of writing material functions, because material functions are insanely handy because you can use them all over the place. So rather than copy and paste nodes all over, we're going to do a material function. So I've created a blank one here called MF angle fade. If you don't know how to create a material function, you just right click in the browser, go down to materials, hit material function, and that's it. So if I now go into here, just get my reference up. That's not what I want. Okay. Everyone still hear me, by the way? Just waiting for a load of spam in the chat. I imagine maybe some people are taking crazy amounts of notes or something. That's what I hope's happening anyway. That's what I imagine in my head. So, material functions, really useful because you can plonk these in all over the place. Now if I go back to the material, just quickly, go back into muzzle flash, what you can do here is right click and create a material function call. And what I can do is plug in a material function that I create into here, and what I'll get is my inputs and outputs here, so I can now use this in all kinds of different materials. Pretty cool. Really, really useful feature. Later on I'm going to show you material, just to overwhelm you a bit, later on I'm going to show material parameter collections as well, which are kind of like material functions. You can use them everywhere, which are really good for storing values. So let's quit out of this a minute and get back to here. So first thing about dot products, let's create one. You always want to feed a dot product with a normalized vector. Now think of a normalized vector as the ranges are limited between -1 and 1. For our purposes it will actually be 0 and 1, but you never want a value that goes over 1, because if you do, you'll normally get a result that you can't really use. The more you can keep values in materials that you want to use for math between 0 and 1, the much easier your lives will be. So, using our dot product node, I'm now going to make vertex normal. Vertex normal, think of the normal of a surface as the direction it's facing. Okay, so if this was 0, 0, 1, it would be facing directly up in world space. Okay, so if I was to place this in the world, 0, 0, 1 would be facing directly up. So vertex normal gives me the actual normal of the surface. Now you're not going to really be able to visualize this very well if I plug it in, but let's do it anyway. So right now the normal of this surface is, I don't know what, oh okay, that's not very useful. Let's use a sphere instead. Actually no, let's use a cube. Cube will be easy. There we go, that's really easy. Okay. Vectors in materials, you visualize them as colors, okay? So blue would be 0, 0, 1 in RGB, which makes that X, Y, Z 0, 0, 1. Green, same thing for Y. Red, same thing for X. So what you can see, if I plug in vertex normal, is I just get the surface normal of these polygons. So here I get Y, which is facing 100% Y direction, X, 100% X, and Z, 100% Z. Okay, so that's our normal that we're going to use. So let's feed that into the first dot product. Break that link because you don't need to see that. This is where things get a little more complicated. So now, camera position. Camera position is literally what it is. It's the position of the camera in world space. So if I was to put a camera in, oh, that's bad. So pretend for a moment that this rifle is a camera. If I was to feed that into this material, that would give me -431 in R, -1 in G, and 122 in B. Pretty cool, right? And that basically just talks to the material. And what this is not for any specific camera. This is the camera that the player is currently looking through when they look at this material. So you don't have to worry about sending specific cameras to this or anything. Now what I want to do is from that camera position. What am I looking for? World position. Absolute world position. This is a pixel. This is going to be a pixel shader. Okay, so basically, absolute world position. This is insanely powerful. Is going to feed out the pixel's position in world space as you're currently looking at it. So this pixel here is, I don't know, -50 units in X and another 20 units or so in Z. So this is going to give me the world position of every single pixel that's using this material. I'm just going to have a quick look at the chat. There's quite a lot going on here that I haven't been looking at. So, link to YouTube, someone's got that. No right corner of the stream, blah blah blah. Does this also take effect for matinee scripted camera? Yes, it does. So this camera position will cover the camera that you're currently looking through. Obviously you can only look through one at a time, but it will apply the effect to that camera. Okay, pretty cool. Now all I want to do is make sure that I'm feeding this a normalized vector. So normalize will bring those huge numbers and drag it back down from the 0 to 1 range. Alright, and then we can just plug that straight into the dot product. Someone's just asked, is this very expensive? No, this is super cheap. This is an effect that you can use all over the place. This is not going to add very many instructions. I'll show you the instruction count when we get to the bottom. But you can push the instruction count these days much higher than you used to be able to. In UDK, if you were reaching 300, it was time to go back a bit. If you were, in Unreal, I've managed to get materials up to sort of 700 instructions, and it's not complained at all. To be fair, I am on a GTX 980, so it can handle pretty much anything I throw at it. But Unreal behaves really well with high instruction counts, so you don't have to worry about that very much. Now, just for the sake of modularity, we're going to do one more thing to this. We're going to add 2 inputs to this material function, which is really simple. You just right click, type input, and you'll get 2 of those. I'm pretty sure there's a shortcut for those, but I can't remember what it is. So these inputs will basically allow us to feed information into this material function so we can slightly change its behavior. So what I've got here is a power and a multiply, and all this is basically going to be a simple curve control. So this is going to be the contrast, and this is going to then multiply it to brighten it up a bit if we push the contrast a bit too far. So this is a vector 3 right now. I want that to be a scalar. I'm just going to name that fade, not contrast, but contrast. And because I'm OCD, I'm going to set its priority to 1. That means it will appear at the top of the list when you make this material function and you apply it in a material. I'm going to make another input. If I'm going too fast, by the way, do say so. I'm quite used to working in this editor now, so I get a bit ahead. I call this one fade brightness. We'll hook these 2 up. I've just read the passenger man said, don't you just want forward camera direction? You could actually do that. That is definitely another way you could do this. So rather than doing these, you could simply get the camera forward vector. Why did I not? You know what? It doesn't matter. I'm going to keep it as it is for now. But yeah, passenger man's right. You can actually use the camera forward vector as well. That will give you exactly the same thing. This is basically what I'm generating here. So you imagine this vector. This vector is the camera position subtracted from the world position. So it's the forward vector of each pixel that you're looking at. Sorry guys, I'm really behind on the stream. And then the last thing we're going to do, just because we've got this power and multiply in here, is we're going to clamp this, because you never, well, for our purposes, we never want this to go anywhere outside of the range of 0 and 1. So let's just plug that straight into the output. Easy peasy. Yeah, right, one thing before we finish. These inputs, you can actually set preview values on them. So I'm going to hit 1 in X, preview that, and hit 1 here. Because otherwise what I'm doing is I'm giving it 0 power. There we go. Now what we've basically built, if this looks familiar to anyone, that's because what we've essentially made is Fresnel. Similar kind of effect, but it just works the opposite way around. Okay, I'll plug that back into there. That easy. Now, all this is really doing, you can kind of start to see it now, as it's given a really soft edge to the outside. What that's basically doing is we're going to use this as a mask and fade things and fade out meshes as you look at them from certain angles. Let's save that. Alright, so is everyone up to speed with me so far? Anything I need to go over again? Or are we all good? Wow, this delay to chat is horrific. This is the problem with living in the UK. You get done over. So really simple. All we're doing here then is vertex normal, dot against which direction the camera is facing relative to the pixel on screen. Really simple. So now, save this, and this is where material functions come in super useful, because now I can come in here to our muzzle flash material. I can create a material function call to what we just built, You can see our inputs and outputs are on here. I already named the output to angle fade before I started the stream. I probably should have shown you that. And even in the right order. Oh no, they're not in the right order. Hang on a minute. I didn't change you. So that's 2. There you go. It just tickles my OCD if I do something and it doesn't actually happen. Now all we've really created here is a mask, so all you have to do is multiply these together. And this is where I pray I've been looking at the right, pretty sure I've been looking at the right material. So now, as you get to the top, you'll see it fades out. Now that effect is pretty lame at the moment, so let's try and tie this back in a little more. Am I doing this the wrong way? So, contrast, let's set this as a scalar parameter that we can control then if we create a material instance of this. Stick those in. I can't remember what the default values I normally use. There you go, that's starting to look a bit better. Someone just said, does the priorities matter? The priorities don't matter, it's just, they're really, the thing is by default Unreal doesn't order them in any particular way. So if you want your inputs on a, if you want the inputs on a material function to be listed in a certain order, you can just set the priority of them. Quincy's asking, how did I create the 6 textures for the muzzle flash? This is really simple. This is, I'll just show you this. This is just a sub-UV texture with 6 different muzzle flashes on it. I honestly can't remember where I got these from. These have been sitting in one of my art folders for donkey's years now. I just used it for the purpose of this stream. So, but sub-UVs, I haven't done anything on sub-UVs. Maybe we'll cover sub-UVs later as well, because they are insanely useful. I remember when I first got into Unreal and the whole concept of sub-UVs just blew my mind. So let's stop previewing this. So now, as I move around, you can see that as I get to the edge, this now starts fading out. So the closer I get to facing away from the surface, the less intense this gets. And what's really cool is we can actually tweak this now. So preview the angle fade, just like that. So I don't know, let's change the contrast up a bit. Let's make it go overboard. See, we've got a little sphere in there, so now, as I get to the edge, bang, all gone. And it really is that simple. Now, this isn't really a very good test. The ultimate test of this material function would be to preview this on the actual particle system. So let's get ready to see some magic. You can kind of see it, but let's hide the let's hide these bullets and these flares. And now, as I start to face down the barrel of the gun, the flash disappears. So you no longer see the edges unless you're insanely close to it. I doubt you'll ever want to be that close to the front of a weapon. Or again in behind. Now you can tweak the fall off of this using the fade contrast and the fade brightness. You can customize this almost any way you want. Really very useful effect. And you can use this for a whole heap of things. Imagine, for example, if you have a sphere that you want to transition through and it's a translucent material. Imagine as you get to the edge, you start to see the actual plane of that sphere. You could hide it out using something like this. Loads of uses for this. It's really simple. Sub-UVs. Maybe I'll do a bit of impromptu sub-UV stuff at the end. Depends how long this takes. I think I've massively underestimated how long it's going to take me to do the planet shader layer. How much I remember. So that's it. Effect number 1 done. Let's get on to something else. Now, when I worked on the blue marble thing, I was having a real problem getting the atmosphere of the planet to actually fade out. And obviously, the Fresnel... Oh, actually, I'll tell you what. Before I get into that, let's talk about Fresnel. Because Fresnel is cool. Fresnel. For years and years I pronounced this as Fresnel. How is it best for me to preview this? Let's chuck that one in. So once again, I'm going to build this as a material function so I can use this all over the place. So Fresnel, what is Fresnel? Fresnel is very simply, it's another type of dot product. How can I do this? What's the best way to prove this? Ooh. Pretty sure I'm doing this right. Nope. Definitely not doing this right. Ah, wait a minute. I have at my disposal. Bear with me. I knew this was going to happen. I'd forget how to Fresnel all of a sudden. Yeah, this is funny because this is something I work with every day, and now I've completely forgotten how to do it. So I'm going to turn to my old friend Google. That's not what I want. Is cell shading essentially applying Fresnel to everything? No, cell shading is pretty complicated. You use a combination of really clever rounding techniques to get that kind of jagged, shaded looking thing. I think I'm going insane. I can't remember how to Fresnel. Come to me. Okay, doesn't matter. Cell shading tutorial. Oh, that'd be something. I haven't actually looked very much at cell shading. That'd be quite interesting. Right, let's bring the dot product back up. Bear with me. I'm now going to have to do this in real time because I'm a bit stupid and I've forgotten how to do this. So I know we take pixel normal into account. Pixel normal is just like vertex normal, except now it's for the pixel. So it's what direction that pixel is facing. That's the simplest way to think about it. Dot cam's here. Demystifying dot cam. Ah, wait a minute. I know what I'm doing now. I think. I hope, because if I don't, this is going to look ridiculous. I'm really not good at this, am I? No, I don't know what I've done there. Okay. I'm really doing this wrong. Ah, I have an idea. Yeah, let's just cheat. Ah, okay, my mistake. Right, now I know what I'm doing. So for now, get back on topic. Camera vector. So camera vector, think of camera vector as the direction that the camera is facing, okay, in world space. So this is simply the direction that the camera is looking at. Right, really simple. Vertex normal, as we've used before, is the direction of the vertex. Now, that's fine if you want to do something with Fresnel for what should we say, like a vertex shader, but for a pixel shader, you want to use the normal of the pixel. Okay, so that's the direction that the pixel is facing in world space. Of course I want to save all changes. That'd be silly. Ah, fooled by autosave. Oh no! Right, let's try that again. Oh, I knew this would happen. I knew that Unreal was going to close on me at least once. It never crashes, I just hit the close button. Let's restore those. Right, we're back. I didn't lose anything good. Yep, that's right. UE4 never crashes. Not ever. Right, let's get back into Fresnel. Now Fresnel is really useful for masking out effects to the edges of meshes. That's basically what we're going to use it for. Now Fresnel by default, I start previewing this again, you can see what we get around the outside is a really hard edge. Okay, now this is really useful if you want to create some kind of funky shield effect or something. You can dial the exponent right up and you get a nice kind of ring. No matter where I look at on this ball, the colour is always pushed out all the way to the edge. Okay, so all Fresnel is a mask, again based on a dot product. And this is great, okay, if you want to use this for an atmosphere shader. However, one problem. Atmosphere doesn't get solid at any point in space and then instantly disappear. The atmosphere fades out as you get towards the edge. So what we're going to do is build a soft-edged Fresnel completely out of nodes. But we're also going to cheat a bit and use the Fresnel node because for some reason I've suddenly forgotten how to make Fresnel out of nodes. I'm clever like that. That's the one thing I didn't take a screenshot of. Right, so we're going to start with the Fresnel. And we are going to get rid of all base reflections. So let me just plug this back in again quickly and show you what that does. Base reflection. Now, if I hit 1, it's going to completely nuke the Fresnel effect. Base reflection is how much of the original colour, or how much of the original whiteness, I suppose, as we're going to use this as a mask, do we want to show in the middle, so wherever the Fresnel effect's not being applied. So I set this back to 0, that will just give us completely solid Fresnel. Okay, really simple. I'm going to set that to 1, so we get the most base effect. Keep shouting at me to save. I really should do that more often. You would have thought that Control S would be like, one day they'll find a way to bind Control S to us as humans mentally, and there'll never be any crash problems ever again. But Unreal never crashes, so it doesn't matter. So first thing I want to do before I do anything with this is invert this Fresnel. Now using a 1- isn't much good for us, so I want to times it by -1. Okay, and all that's going to do is invert this. So it's going to drag it down. Stop that. But now I want to use it, so I'm going to add 1. And that effect looks familiar, does it not? Connect the output. Okay, cool. So what I can use this for now is the opposite effect. Check that out. I've now got just this infinitely small point that fades out into nothing. But we are not done yet. You know, I have a funny feeling I'm going to have to go open one of my other projects in a minute for a reference, because there's no way I wrote enough stuff down. So, before I do anything, I want to really brighten this up now. Make this insanely bright so we've got lots of stuff to work with. I'll explain all of this in a minute. There is method in my madness. Well, that doesn't look very exciting, however. What we have, I'm going to create another input so we can control this a little. Probably create some more inputs on this later. Let's call this soft edge core brightness. We'll give that a default value of 20. Oh. That looks crazy. Right, give me a moment. I have to open another project now so I can double check what I'm doing. It's a good thing I'm not under NDA. Basically what this is going to do in the end is give us a Fresnel with a really nice soft edge on it. So we can use this later in our atmosphere shader, which will probably be easier to build than this. So let's get this one open. And we need to go to yeah, right, now I know what I've done. Set this to something really small. That's what I'm talking about. So I should be able to brighten this up. There we go. So now I've got a Fresnel that I can basically push as far as I want, but no matter what, when I get to the edges, it will always be it will always fade out to black. So I can push this really far, but no matter how far I push it towards the edge, everything will be completely faded out when we use this as a mask later. Okay, now we want to clamp the end result, because if we don't, we're going to get a lot of problems. There you go. So you see, the more I push this value, you can see, you might not be able to see so well in the stream, but the edges here, we always fade out to black, no matter how hard I push this. And this is really useful because it basically means that for an atmosphere, I can control how dense the atmosphere is going to be at ground level. I'd really love to show everybody how you build a Fresnel purely using nodes, but I have had a brain fart and completely forgotten. So we'll do that once this part's over. Right, now, just for the sake of it, we're now going to add a few more inputs to this so we can control this later. So let's add one for the exponent for the outer Fresnel. Let's make this 0.001 by default. Put that at the top. Call this outer exponent. Chuck that in there. None of this other stuff we really want to change, I suppose. Do we want to really play with this? No, I think we'll leave that at 20 because that's how I've done it before. We don't want any base reflection. Right, now as I have this open, I'm going to try and open up the actual Earth map. I'm going to show you guys how you can really use this. So this is going to eat through about 11 gigabytes of my RAM, so I really hope the stream doesn't drop out. Let's flick back to the other project while this is opening up. Now one other thing I can show you actually while we're here is how to expose material functions to the library. So you see before how when I go into material muzzle flash, if I get up the palette on the right and I search for material functions, these are all the material functions that come with Unreal by default, so I haven't built any custom ones into here. By the way, some of these are seriously awesome, like I haven't even there we go. Let's just let all these textures load in. So if anybody asks you what I think of the new GTX 980 card, it doesn't handle transferring big chunks of memory and throwing it around all over the place. I'm actually getting better performance on this on an older card. So let's have a look at the atmosphere. So if I go inside the Earth, this effect completely breaks, but you can see that the Fresnel is coming from the center and it's pushing this effect right up to the surface. So on the surface we actually get some level of thickness, and it then fades off as we go out into outer space. Really useful for an effect like this. Obviously, like I say, if I go inside, the effect's completely balked, but you're never going to see that unless you want to create space Minecraft or something, at which point you'll have to work that one out because I haven't come to that point yet. But that basically shows off the effect, so I don't know if I can handle having all these open at once. Let's see how we get on. So I'm jumping around a little bit here, but yeah, these material functions that come with Unreal are insanely useful. There's some stuff in here that I haven't really got a chance to look at yet, but there is some cool stuff in here. I really recommend having a play around with them. But before, when I wanted to invoke this angle fade that we built earlier, I had to specifically type in material function call, then search for it in the content browser, and that's a pretty long-winded way of doing it. A better way to do this, if you're going to be using material functions all the time, is you can simply expose them to this list. So you can just drag them in straight from the palette. So if I want a smooth curve, I can literally just drag that straight in. So if you're building a lot of functions or you've got a content browser that's full of stuff, this makes it much easier to navigate through. So let's expose angle fade. And you do this down here in the material function settings. You just hit expose to library. You can give it a description if you want to, so when you hover over it, it'll tell you what it does. So we'll just say this one fades out a mesh at glancing angles. And even cooler than that, we can give it categories. So let's give it custom, put it under masks, put it under misc, and now if I save this, and we should now be able to search for this in here. I might have to close and reopen. Oh, auto save once again, telling me to hit Control S. What on earth did I call it? I can't remember. Let's reopen this, save. Yeah, getting a bit of misbehaviour now because I've got the Earth map open, but dot demo. In fact, I might just be able to type it in. Yeah, there you go, MF angle fade. So now I can literally just drag this straight in, and it should also appear in the palette. Get the palette back up. MF angle fade. I can just drag these in, and now I can use these all over the place. So alongside angle fade, let's also expose soft edge Fresnel. So we'll just say creates, not creates, creates a soft edge Fresnel for use as a mask, which is exactly what we're going to use it for in a minute. Expose to library, let's put it under masks and custom as well. Awesome. So, how's everybody feeling so far? So far I've had a couple of brain farts, but I think we're doing alright. So what do you think then? Should we start building an atmosphere shader, or is there something anybody else wants me to go over first? Just say so in the stream. Otherwise we'll get started on this atmosphere shader. Now I've got the other project open, I can just copy paste as well, so hopefully I won't make any more mistakes. He says, hopefully. So look at this. How big is your Earth? Pretty damn big. So currently, if I look at my CPU usage meter that I've got, I'm currently using 13 gigabytes of my system memory with this map open. Simply because there's a 65,000 pixel resolution around the circumference of this in any direction. So there's about 96 4K maps that cover this in total. Although, without that, you wouldn't be able to do stuff like this. So it's so ultimately worth it, because let's be honest, that looks pretty cool. Never get tired of looking at stuff like this. Next question in the stream. Notice you have two machines, one with a Xeon and one with an i7. I would go for an i7 on the basis of the Xeon CPUs have a really slow clock speed, like 2.2 gigahertz, and they're pretty slow at virtually everything. They do have 12 cores, which is awesome if you have a multi-threaded application, but Unreal can only use 2 threads at once at the moment anyway. So right. So, just for reference, I'm going to keep that one open. However, I'm now going to show you how to build an atmosphere shader. So for this isn't going to be quite as in-depth as the Earth one, although I'm quite happy to go over and explain a few things, but I'm just going to go from the ground up and try to do this from the bottom. Can you send me a nice screenshot of the night side of the planet? I do actually have some in work. Maybe I should put those up. There is a thread up for that Earth on the forums, by the way. It's in the work in progress section. So, now I'm going to show you how I have tricked you all into thinking that there's a real atmosphere around this. And when I select it, you'll notice that there's a bigger sphere around the inner one. What that is basically an inverted sphere. So if I come back into our other project, what I've actually got here, although it looks like two oddly shaped objects, is two spheres. Right? This is a blueprint. So open up the blueprint. Go to components view and come away a bit. This is much easier to see here. So you see, all I've got is an inner sphere, which is just a sphere mesh with a few segments. There's no UV maps on this. I'm just going to show this as black for now. And then on the outside of that, I've got another sphere with the faces inverted, so they're flipped to face inward. So if I come on the inside, it's just basically an inward-facing sphere. Okay, but obviously as I move out to the outside, you can't see those back faces, so you just see the inner. Now this is basically what's going to help us cheat and hide that big glow in the middle. Okay, you also know they're both the same scale. All I've done is scale the outer one up ever so slightly. That's probably going to be quite prominent, but we'll leave that for now just so we can see it really well. Okay, that's all this blueprint does. Now, one other thing we need to look at before we can start building an atmosphere shader is what's called material collection parameters. Now, these things are, I would have killed for these in UDK. They are so useful. I'm amazed I don't see many people using them. So I'm going to create a new one and show you exactly what they do. Because of my OCD, I'm going to put it in a folder all of its own. So to create one, you just come in to Materials and Textures, Material Parameter Collection, and we'll call this MPC. Let's call it Sun Direction, and this will all make sense in a minute. So Material Collection Parameters. This is a Material Collection Parameter. Not very exciting. However, what you can do is in here you can store variables that materials can access, right? So these are global variables that any material can get to. There are some limitations. A material can only read 2 values from a material parameter collection, from an MPC at once. Okay, so to demonstrate this, if I create the vector parameter that we're going to need, I'm going to call this light direction. So light direction is going to be a light vector, which is what we're going to create in a minute. So if I set this for now to just be 1 in R, which would equate to 1 in X, and alpha doesn't matter. Save that. Now if I go into a material, say let's go into the atmosphere shader, which is currently blank. Now to get to that value, all I have to do is type in, hang on, let me find it, what did I call it? Sun direction. All I have to do then is type in collection parameter and I will get this. And because I had that parameter selected in the content browser, it's automatically filled it in. But normally you can come down here and select one of the collection parameters you've got from here. So yeah, you can only, I'm noticing a bit of this stuff in the chat. So you can only read 2 variables from an MPC in any one material. Okay, you can store as many as you want in a collection parameter, but you can only read 2. Okay, now they can be 2 vectors, they can be 2 scalars, it can be 1 scalar, 1 vector, it doesn't matter, but you can only access 2 of them at once. I don't know if that limitation is going to change later. The last time I looked at it, it was only 2. Someone in the chat is saying it might be bigger. It might be bigger now, but the last time I checked, this was only 2. So take that with a pinch of salt. Okay. Now, all I want to do is I want to read the light direction, which is going to be our custom parameter that we're going to feed in. Light direction, straight from there. And all this is now going to do is just spit out the value of that. So if I plug it into base color, you'll see we get red. And I can come into here and I can change this to, I don't know, 0.5. Let's make it some kind of bluey color, and it will update in all the materials that reference that value. So this is really useful. Say I have loads of planets in my scene and they all need to know where the sun is coming from. Rather than me feeding that into 10 different materials on 10 different objects, it's much more efficient to create a collection parameter that all the materials read from, because then you only have to do 1 tick function to update it. And actually in our case we're not even going to update on ticks, this is going to be super optimized. Another question, is this per frame? I'm assuming you mean the shaders. Shaders are per frame. So this is currently 37 instruction material. That means that the GPU is performing 37 instructions for each pixel of this material. It doesn't really equate that way because of the magic of caching and the fact that Epic's rendering engineers really know what they're doing. So it's not as expensive as it sounds, but yeah, the materials work per frame. Okay, so that's what a collection parameter does. Another good thing to look at for collection parameters is Epic's Tappy Chicken example. Shane Caudle, I think, made that, and he uses collection parameters quite a lot for that, for changing things like time of day and stuff like that. They're really useful. Let me get this open on the other screen. So why do I even need to use this? I'll show you why. What I need to do is create a dot product from the sun's direction on the surface, okay? Because I only want this atmosphere to show up on the sunny side, okay? If you were in the night side, you wouldn't see that atmosphere, and this is going to be an emissive effect. So unless I mask it out, you'll see it everywhere. Now, what's also cool is because the dot product is going to give us a value that ranges from 1 to 0, we're going to get a gradient that looks not so similar to this. What you can do with gradients is you can map colors to gradients, so we can actually make it really blue at this side, we can make it really orange at the top here, where effectively it would be dawn as far as the planet's concerned. So that's what we're going to do. To do so, however, we need to create a light vector. Now, light vectors are something that you can only
feed in to the material editor using a forward renderer. However, because we have Blueprint, we can use the majesty of Blueprint to save us. So what I'm going to do, you'll notice on this blueprint I've exposed two variables, okay? So one is sunlight, which is a directional light, okay? So that could be any directional light within this level. We've only got one, so I've got this one selected right now. And the other one is refresh sun, which will just run our construction script whenever I tick it. The only purpose of this is to talk to our parameter, our parameter collection. I'm going to keep muddling that up. Our material parameter collection, and tell it where the sun is. Okay, now let's start by actually creating that light vector. This is really simple. All I'm going to do is that sunlight variable that I've got. Let's get that. I'm assuming people are fairly comfortable with blueprints, by the way. If you're coming from Tesla's stream, you probably are. Now I want to get the rotation of this. And rotation isn't enough. We need one more thing. We need to get the direction. Now the easiest way to do that is just get the x vector, which is basically saying get as a vector the direction that this thing is facing. And then I'm going to set that to be the value in our material collection parameter. So in order to do so, if I just type in set vector parameter value, and this will ask me for a parameter collection reference to plug in. So I'm just going to plug in our one there. And what's really cool about this is it actually comes up with the names that you've typed in already, which is really sweet. We're going to plug our x vector into that. We're not quite done yet. We need to do one more thing. And this is a little kind of hack you can do to get your construction script to run again, even after you've placed something in the world. So I've just got a branch here with refresh sun, and the thing is any time I change a property, this construction script will run again. So every time I turn refresh sun on, I want it to immediately turn it back off and update the collection parameter, and just for good measure we'll plug it into there as well, so that happens every time we click. And that really is it. So with that we can now talk to any material and tell it what direction the sun is facing in the world. Let's close that. I'm not sure if it actually updates in here. No, it doesn't. I don't think it would. Okay, so basically what will happen is as I move this sun around, this Earth will talk to that collection parameter and tell it what direction we're facing as a vector. So I can then get this in a material and do things with it. Let's close this. So we're going to build, how many are we going to do? We're going to build probably one more material function that we can use all over the place again for different types of atmospheres and things like that. So I'm going to create another material function, and what we're going to do is use this to access that light vector. Sorry, not access the light vector. We're going to use this to calculate the light direction in the material. Okay, really simple. Sounds more complicated than it actually is. So I'm going to call this MF light direction. And let's give this a name. Let's call this the normalized direction. So what do I want from this? Oh no, sorry, scratch that. Let's call this the non-normalized direction, because I'm actually going to do something a bit crafty with this. So one other thing I need to do, if I go back to this parameter collection, you remember I said earlier that we can read in two parameters. Again, that might be different now. The last time I used it was two, but for the sake of this we only need two, so that suits us fine. We're going to create a scalar parameter called Earth, or let's not call it Earth, that's down to habit. Let's call it planet scale. And I'll set this to a default value of about, I don't know, let's leave it 10 for now. I don't know actually, do I want to do this through a collection parameter? Probably not. Let's leave it in there. We don't necessarily need to use that. I'm going to go off script a little bit here and do this a little bit differently to what I had planned. I'm going to create a multiply. Let's see, what's the best way to do this? I'll put not normalized. I want this one. It's been so long since I've done this. It has an NPC with over 60 params. Can you actually read from all 60 of those in one material? Or can you only pick from 2? Maybe that limit's gone since I last used them. What am I doing here? What do I actually want for this? Normalize, right, okay. Let me build this and then explain exactly what we're doing. See, nothing's ever easy. Yeah, you know what? We're going to use that parameter. So I want to, this is really cool. In the material function, you can actually, oh, you can use more than 2 per material. Awesome. Cool, that's really cool actually, I didn't know that. So that's, there you go, even I've learnt something. Collection parameter. This time, I'm going to get the planet scale. And I want to do it. Oh yeah. Active world position. Oh, hang about. It's funny, you go back to materials that you wrote some time ago and you can think of millions of different ways to do them better, but we're midway through the stream, so maybe I'll plan a bit better what I'm doing next week. So I'm going to divide that by Earth scale and subsequently divide that by you don't really need to know what I'm doing here, this is kind of setting this up. Multiply those together. This is where things are going to get messy. Multiply those again. I must have tweaked these values. There we go. Now I want to divide these by each other. Oh, already got one. It's kind of pointless me explaining what I'm doing here, so I'll just show you in the final result instead. And then stick that in there. And it would help if I actually plug something into that. Oh. It's better. How crazy is that? No, I should just stop right here. That material's pretty crazy on its own. How do I keep my material network? Oh, God. Right. Oh, exciting stuff aside, let's actually make this atmosphere shader. So first thing I'm going to want is that Fresnel that we built earlier. So if I just hit soft edge Fresnel, bring that in. I'm going to need that in a minute. Do I want to fade this out at all? Probably not. So we're already clamped. Let's give ourselves some extra adjustment on this. So let's make a parameter for that. Chuck that in there so we can control how much we're pushing the effect out to the edges. Let's add another one for this to final contrast so we can tweak things again right at the end. And then also so we can brighten things up. These aren't specific values, by the way. I'm just copying these from the shader that I've built previously, just to save a bit of time. It's turning into a long stream. There we go. Right, now what I'm going to do is use that to control the opacity of this material. Okay, so that is going to handle all the funky parts for us. Let's see, maybe I do want to clamp this actually. Or do I? Probably not, no. It's not going to make a difference in the end anyway, so let's chuck that in there. Let's make sure that value is the right one. Not one. There we go. Cool, that's everything we need. I know why this is looking crazy. Right. Do you stream these things often? No, but if people like watching this, then I will, because I'm actually quite enjoying it. So for this to work, we need to make this an unlit material, because we're not going to take any lighting information to it. Well, we are, but not the kind of lighting information we normally use. And we also want it to be additive. Okay, additive materials are fairly cheap. They just add their color information on top of pixels behind it. Really good for things like fire, where you want things to be insanely bright. So there you go, that's looking a bit better now. It looks more like what we want. Pretty cool. So now let's build the more interesting side, which is the color. So I want to read in the light direction, so this is going to be the light vector. Now, one thing with collection parameters is you still need to add masks to them, because this is giving me a float 4. I only want a float 3, because otherwise I'm going to get an error at the end. More streams, please. Ah, cool. Good, I'm glad people are enjoying this. Hopefully the next one won't be so choppy. I'll get a bit more used to what I'm doing. So once again, we're going to come back to the awesome dot product. And we're going to plug in the normalized light direction. Now, we don't technically need to normalize this because it'll never come in at a higher value, but just in case someone wants to modify this later, I'm just going to normalize it here just for safety, I suppose. So we also need that light direction material function. Let's chuck that one in there, and let's expose bias value a bit. Set that to, I can't remember what the default was, something like 250. There you go, now we're starting to see things. So that is the dot product of the light vector against the surface of the sphere, right? Very simple. And the bias value essentially allows us to tweak the range of the dot product over the surface. Okay, so you can see as I drag that up, it starts to get more and more fall off towards. It kind of starts darker and finishes quicker. As I drag that down, you get a much tighter line there across that, and you also get a brighter thing here. Now, what you can see is we've basically made a gradient across the surface of this sphere. And you know what? Just for the sake of it, I'll show you how these collection parameters work as well. So let's change the value in that collection parameter to, I don't know, what should we make it to? Try and get these up in the same. Try and get these up in the same space. You can see it happening. So that's our basic mask. Okay, now let's change the direction. So let's make it Y, or we could make it Z. Sorry, or we could make it, I don't know, halfway between. So as I drag this around, what's cool about these, by the way, is they update in real time. So as I drag this around, you can see our vector is moving. And because Blueprint's talking to this, what I'm essentially able to do is send Blueprint information to a material, which is basically what the purpose of the collection parameter is. Do more streams. Sweet. I'm glad people are liking this. Because I'm a tidiness freak, I'm just going to move these in a bit. So let's add some more customizability to our mask that we've made here. So because this is simply a stream of numbers, we can just add some more values to this. So let's call this position offset. All this is going to do is simply add a value to our dot product so we can offset its position. So 0.55. And you can see that now it gets brighter here, and we're modifying it independently of this bias value. So as I drag it up, it's quite hard to see here, but you can see the effect change. Oh no, you can't, because I'm not, that's better. That makes more sense. Yep. So what this allows us to do now is push the effect back over the horizon. Okay, so I had this set to 0.55, that's enormous. Now I remember what the purpose of all this stuff was. See, it's all coming back to me now. So the position offset essentially allows us to move this back over the horizon. So if I just load the Earth back up quickly, on the Earth you'll notice as I get to the top, can't see there because of the northern lights, but as we get to the edges you can kind of see the atmosphere actually carries over a little bit onto the dark side. Wow, got a Star Wars reference in there and I wasn't even trying. But you can see it carries over onto the dark side and fades out. Obviously that's to simulate the idea of the light scattering through the atmosphere and actually being carried over to the night side. There's not a hard cut off. So what we can do, position offset, is basically move that gradient across the surface. So let's set it to something fairly small, like 0.15. And that'll just push it ever so slightly over the center of the sphere. Let's hook this one back up. So the last thing we're going to do, and I didn't prepare this, so I need to import this very quickly. So what I've got here, I'm going to have to show you in the content browser because I can't really think of a better way to show you, is a simple gradient texture. Okay, and this is something you can do really easily in Photoshop. In fact, you know what? Let's make one in Photoshop. So we're going to create the colours of the atmosphere that we're going to use inside of Photoshop because that's just magic. Let's create a new document. I'm expecting at least one instance of Unreal to commit suicide on me in a minute, so we'll see what happens. How much RAM am I eating through right now? 14.5 gigabytes. Not bad, not bad. We can push it to 16. I don't actually have a page file, so it might just die on me. Let's see. It's back in Photoshop. Gradient, really simple. Just going to double click on this layer. Create a new gradient overlay. Let's change the. Actually, let's make this a bit bigger so we get nicer. We get a nicer effect. And fill that in. Hide the grid. Apply a gradient. Let's make sure it's facing the right way. So what we're basically going to create is a color lookup table. I won't go too in depth with this because I'll probably do a stream on this when I do something on post-process, because that's what they're really useful for. But basically what we're going to do is we're going to create a, as far as the material is concerned, a list of colors that it can draw information from, and then it's going to map it across that gradient. So what we can basically do with that is we can have it, the atmosphere will look really blue on the the atmosphere will look really blue when it's directly facing the sun, but then as it fades off it'll start to tint to a more orange colour. Also, Owen Bick1 in the chat, by the way, is a guy I work with in work. That's what he's talking about, where he's saying it looks familiar. I've had to ban 4 people that I work with already because they're trying to harass me. Jelly of my elite skills, that's all it is. Oh wow, look at that, I've actually already got a gradient here that I used before. Now that's cheating, let's make a new one. Let's see. So I want this to be completely black on this side, and I want to have a nice kind of orange colour in the middle. Ooh, that's very orange. If you want, later on we'll make this something totally crazy. Let's dial the colour back a little. And at the very end we'll make it that nice, typical, earthy, bluey, purpley colour. I'm quite partial to that blue. And let's drag these around a little bit. Get a bit too extreme with that one. I don't know if these set before. Aha, that would make more sense if I just drag that one in. Oh, I lost my colour. There we go, that's better. That looks fairly atmospheric-y. Probably go a little bit. Oh, that's a bit too pink now. Ah, keep losing my colour. Oh, I know what I've done. That's better. Let's make that. Let's make it obnoxiously blue on that side. There we go. There we go, and that's our gradient. So, I'm just going to... Should I save this? Yes, I will save this, because it'd be silly if I didn't. Just save this as a PSD for now. So, stream... atmosphere LUT, save that. Now before I save this as a TGA so I can import it, I need to resize the image. So as this is a lookup table, we only need one line of information. Okay, so we only need oh no, don't want to do that. We only need one length of pixel, because the color's going to be, because this is a gradient, the color's going to be the same from top to bottom. So we don't need another 1023 lines of pixels. It's just going to be taking up unnecessary amounts of memory. So we can make this a tiny little image. This might be too small for everyone to see on the stream, but basically what I've got now is a 1 pixel thick gradient that goes from blue to orange to black. Okay, and now save this as a TGA. Doesn't really matter what you use, it can be TGA or PNG, one of the two. Let's call this T2D underscore Atmo gradient. Save. 24-bit. And close Photoshop because my PC's going to give up without RAM in a minute. And then we want to import this into the content browser. Where are you? There, atmosphere gradient. Oh, if memory serves me correctly, we need to tweak a couple of settings on here. Okay, so don't you think about it. Save all. Save. So bitmaps. We don't want any bitmaps for this because it's a lookup table, so let's change this to no bitmaps. That way we won't get any banding or artifacts the more we move away from the object. I'm going to change the texture group to, what should I change it to? I won't use lookup table, I'll use cinematic. You probably don't want to use that very often. This is a really tiny texture, so it doesn't really make a huge amount of difference, but you don't want to use that too often. And the last thing I want to do is change the compression type to vector displacement map. Vector displacement map is essentially, for all intents and purposes, uncompressed, so we don't get any artifacts or anything like that. Okay, it doesn't use the DXT format, it uses a different format. And what we get is much better color information. So we don't lose any of that nice gradient that we made in Photoshop. So now if we plug that in here, you can see our gradients coming up there. We plug our dot product into it. This is going to go a little bit crazy, but now you can see we have a band of colour. That doesn't actually look the right way round, does it? Well, it's back to front. Never mind, I'll come to that bit later. Hang on a minute. I think I need to clamp this. Do I not? No, I don't. I might be using an old gradient for this. Anyway, let's chuck that into emissive and that into opacity. Now this is where we have to start playing with things a bit. This is where we have to start tweaking the scale. Ah, there we go. Now it's looking a bit better. Still facing the wrong way. I should have done that gradient the other way around. Let's switch it real quick. Let's go back into Photoshop. Good thing I saved that, wasn't it? Let's just quickly switch those colours around. That doesn't really make an awful lot of sense, actually. Hang on a minute. Oh, interesting. Okay, well you can kind of see what's happening. As I reduce the bias value, we're getting more and more of those gradients appearing, and we actually only want one. The reason this bias value exists is because if you have spheres of different sizes, you're going to want to make the you might want to make the atmosphere stretch ever so slightly differently across those different sized planets. So let's drag this up to something a bit more sensible. Not that high. Actually, this isn't really going to matter too much when we get it into the world anyway, but there we go. There's our gradient applied to the surface as colour. Pretty simple. Let's save this. This is where we're going to have to start tweaking things now. So the next step, let's close this. Oh, hang about. No, I know what I've done wrong. Atmosphere, materials. Oh, come on. That's blue. No, that's the right material. Okay, let's apply it. Yeah, no, I don't want to flip the image. I want to leave it as it is. Wouldn't really make much sense for it to come in that way around, but we'll tweak that in a minute. Might not actually need to. I might be doing this right after all. So now, let's go into our blueprint and actually apply that material to the outer sphere. And this is where everything goes horribly wrong. Hopefully not. Actually, before we do that, let's be a bit crafty about this. Let's make a material instance of that so we can adjust things on the fly. Oh, my other version of Unreal isn't happy. Let's close that temporarily. Don't need that to see that anymore anyway. Parent material. I want to find our atmosphere material. Oh, no. Oh dear. Hang on. What did I call it? That one there. There we go. Now that's starting to look more like an atmosphere, is it not? And see, what we've basically got now is this fuzzy ball. And we haven't actually done anything. All we have, you can actually apply this to other shapes too. That's interesting. Oh, I thought that was a teapot mesh then. But you can kind of see what this is doing. Basically what we've done is we've mapped the gradient across the dot product of the light vector to the surface of the sphere, to the direction of the light. That's really all we've done, and we've used that as a gradient to put colours across this. So we can now tweak all these values and adjust this as we like. I really don't understand why it's that way around. That makes no sense, unless I bodged this in my actual project, in which case I need to go back and fix it, but there you go. Something's not quite right because we're getting a really hard fall off there. Ah, hello. That's what I want. See, it always makes so much more sense if you just take it into the material instance and just screw with the values. There you go, that looks a bit better. Let's reduce that a little. Let's make the gradient a bit tighter. Move it over. Not quite over far enough. Rather than me do it to this sphere, actually, let's actually apply it to our actual sphere in the engine. So let's chuck that material instance on there. Yeah, of course it would look completely different. So now in the world, let's do two things. Let's update that. That's all set. There we go, now things are starting to take a bit better shape. So let's increase the bias so we get the full effect. Yeah, I might have to tighten this gradient up a little bit. Push the effect out to the edges. Offset that a bit. I need a bit more gradient to play with here. I might have to make that gradient a bit longer in Photoshop. Let's kind of get some bluiness going on. Not looking too bad. Just sort that problem out. Soften the effect off. So you can see that's really subtle. By the way, subtlety goes a long way when it comes to materials. You're right, I think this needs a bit of atmosphere scattering across the surface as well. It doesn't really sell itself yet. Just think about how hard that would actually be to implement. But that's you know, our atmosphere shader in a nutshell. You can see the closer we get, it kind of fades off into space, and the more you move into it, then you get inside the Earth, where you'd obviously not want to be. Let's see what else we can do with this. So one thing I did for the Earth material is also... Oh, I haven't got it open, have I? One thing I did for the Earth material is I also applied it to the surface. Because obviously, how do I explain this? So light doesn't just scatter across a giant sphere. It kind of scatters across the surface of the Earth as well. I'm going to have to open up this project again. Let's try and do this really quickly. That way we can kind of get a nice big lead planet floating in the middle of nowhere. I suppose what I can show you quickly while this is loading is as I spin this light around, you'll notice, you won't notice it yet, but if I now click on this and hit refresh, our atmosphere moves to the new position of the sun. Now if you wanted to, you could drive refresh on tick, or you could drive it from a game instance. Someone suggested earlier actually feeding the parameter via the game mode or the game instance, which is also possible. So let's have a look at applying this to the surface as well. I'm about to open an insanely complicated material. Oh my goodness, I forgot how complicated this was. Let's oh, thank you. I just dragged this over. So this is the material network for the surface of the Earth. So I think in the interest of time, I probably am not going to go through this entire thing and show you how I got the atmosphere on the Earth today. Although you can see as I moved around on this small segment of the Earth, you can see the atmosphere on the surface there as I kind of move around. Yeah, I don't think it's wise for me to go over this anytime soon. Oh dear me. This needs a lot of cleaning up actually. Yeah, I think I'll come back to that. Anyway, for now we have a pretty sweet atmosphere scattering effect around the outside of our orb. Now one more thing I want to try. Kind of want to tweak that gradient a bit because it doesn't look too great. Let's drag it. Oh, let's drag it back a little bit so we get a bit more room to play with. A bit more purple. Let's reduce the saturation a bit. Let's pump it up on here. So we're just going to really go to town on this now. You can actually create gradients inside the engine. You have to use a little bit of HLSL code to get them working. But I could probably show you that on another stream. HLSL is a difficult beast. I don't really understand all that much about it yet. Oh, that looks a bit nicer. Look, we get a much cooler blue tint around the edges now. Let's see if we can tweak the material on that ball so we get the full effect. Let's nuke that specular out. Oh, no, wrong way. That's better, you can kind of see it now. There you go, and that's basically the same technique I used to do the Earth. And you could probably do all kinds of things with this actually. I haven't really explored much of it yet. So just to end up the stream, let's do something completely crazy. Let's make this a super alien planet. I suppose one thing I should probably ask right now is there anything anybody wants me to go back and explain in more detail. I'd really like to actually do the Fresnel thing properly, but I have completely forgotten how to do it, so I'm going to have to come back to that another day, I think. Oh yeah. Now we're talking. Yeah, why not? We We've made the change. Commit to the change. Oh wow. That looks positively horrible, but that's exactly what we wanted. Although that could be really cool for like a slime ball or something. A funky slime effect. Obviously another thing you'll notice as well is as you move around, the effect will actually carry through as well, so you can be behind the earth and you get that. Now that is a pretty cool effect. Pretty obnoxious at the moment. We can kind of dial it back a little bit. Let's just reduce the size of the sphere. That's cool. Looks like a black hole or something. It's too small now. You can't see the green. Let's dial it back up. Let's make it enormous. Yeah, that's not going to work. Okay. Now, on reflection, looking back at this, there are probably a few steps that you guys could skip. So what I'll probably do is I'd like people to actually get their hands on this content, because I believe in people actually playing around with things themselves to actually learn about how stuff works. So what I'm going to do is I'll tidy up this package a bit, and then I'll export it and I'll put it up in the thread as a link that people can download and they can actually poke around. One thing I will probably do as well is rebuild Fresnel in node form so you can really see how it works, and also drop that in here as well so people can use this stuff for whatever they want. And you even get a free muzzle flash particle with it as well. Although I'm afraid I will have to take out the prototype weapons because that doesn't belong to me. But if people want that, I can do that as well. I can actually upload the project and people can have a dig around. I'll tidy things up a little bit. So I think that's probably a good place to end. Please, by the way, leave feedback in the thread for how you think I did. This is my first stream, so hopefully the next one will be a little bit more cohesive and I'll actually not forget things. I'm not really sure what I'm going to go over in the next one, or when it's going to be. If anyone's got any suggestions, feel free to stick them in a thread. I can cover all sorts of things. I can go into C++, we can do some blueprint stuff, we can do more materials, we can do particles. Animation I don't know an awful lot about. We can just do some general engine stuff. Anything you guys want to do. Or I could do a more detailed breakdown of the Earth or something, or another scene. But anything you guys want to see, just leave it in the thread on the forums, which I will now link in chat. I can't put the finished Earth in that package, I'm afraid. Which is a shame, actually. I really wanted to marketplace that thing, but I can't do that just yet. Not at all. Thanks for watching, guys. It means a lot. This is my first one. Reached about 45 people at one point, so that's a pretty good start. No, let's not do that, actually. I know what I was going to do. I was going to link you all the thread. It seems I spend more of my time on the Unreal Engine forums than anywhere else on the internet these days. There it is. Advanced materials, simplified version of the Earth. Oh, does such a thing exist? That project was such a beast. That took about 3 months of work to get that thing working. But I would love to show people how I got around to doing it and how it's achieved, so definitely something I'll probably do in a future stream if people are interested. And yes, by the way, people keep asking, these will be on YouTube. I'll be archiving everything on YouTube. So you'll be able to watch them at any time. You'll be able to watch it back, see how I did the nodes. Obviously, like I said, I'm going to put this project up for download as well within the next... I'll do it over the weekend, actually. I'll get the project ready for people to download over the weekend, and you can kind of have a poke around. Maybe we'll have a master project or something that I'll update every few weeks or however often we do these streams. Doing one weekly would be quite good, but I'm not sure if I've got the time, so... And I might do a different day as well, because Thursday's getting pretty busy now with Unreal and Tesla stream all in one night. It's quite a lot to take in, so I might start doing these on a Friday or whatever day people find useful, possibly a better time as well. It's quite late now. So I hope that was useful to people. I hope people learnt something. Hopefully the stream went really well. I'll watch it back later and no doubt they'll cringe, but hopefully it went okay. Thread, another piece of thread, yeah. So yeah, just post any ideas, any stuff you want to see, post it in the thread. I've got some ideas of my own already, and thanks for watching. I'll catch you all next time.